Hi guys, today I want to discuss the mind-boggling granite blocks of the Great Pyramids and temples on the Giza plateau. Granite is a very hard igneous rock and considered one of the most difficult stones to carve. Thus it is surprising and intriguing to see the impressive granite workmanship in the magnificent Giza pyramids and temples. Some granite blocks amaze people with their sheer size and weight, like the big beams on top of the King's Chamber of the Great Pyramid. Each weigh on average 70 tons. Some granite works astound us with their unbelievable precision cuts and fittings that are so fine that the conjoining lines become barely noticeable, like what can be observed in the Valley Temple. Some granite blocks have bizarre puffy and pillowy looks with indentations and knobs, such as the ones at the Menkaure Pyramid. There are also loose granite pieces exhibiting incredible evenly curved surfaces. The rose granite used in Giza structures are supposedly quarried and ferried from Aswan over 900 kilometers or 560 miles away. How are these heavy stones shipped all the way from Aswan and hauled up to the 60-meter high Giza plateau? How did these hard granite blocks get cut, carved, and positioned so precisely 4,500 years ago? Egyptologists claim that the stones were carved with bronze hand tools in dynastic times. But many experienced stonemasons and construction professionals argue that is simply impossible, because the extreme precision presented at these ancient sites can hardly be matched even if created with modern technologies. On the topic of judging how these megalithic structures were built, I would value the insights of individuals who worked with stone extensively before that of historians and Egyptologists. At the end of the day, this discussion should boil down to reality and practicality, since we're dealing with existing granite projects. So, if ancient Egyptians did not carve and position these large granite blocks on the Giza plateau, and instead they just inherited and repurposed them, then the real creators must have lived before the dynastic Egyptians. Was it a lost advanced civilization? And if so, how advanced were they? What methods did they use to create these majestic granite works? Are there clues on site to help us decipher how the amazing masonry was done? In this video, I'll share my thoughts and findings with you, and as always, I welcome your feedback. Let's check out the granite work, which perplexes us the most. The Valley Temple of Khafre is considered the best preserved Valley Temple of Egypt. The outside walls were built with massive limestone blocks and sheathed with pink granite. The sheathing granite blocks are made to fit, fill, and protect the eroded limestone behind. In the central courtyard, the granite blocks may appear a little rough and weathered from a distance, though in close-up shots we can see their conjoining lines are super accurate and so precise that a hair could not fit between them. The seams are almost too fine to be noticeable. How was this done 4,500 years ago? Archaeologists have performed an experiment to cut a granite block using a big bronze saw, a tool ancient Egyptians might have possessed. With two people working on the saw and others adding sand and water to lubricate and enhance the grinding power, they cut merely 4 millimeters of stone in an hour, and in several days the team managed to saw a few inches down the stone block. Needless to say, the cutting surfaces resulting from this tenuous effort could not match the laser accuracy witnessed at the Valley Temple. Besides the exquisite precision joining lines, there are many polygonal blocks that fit tightly and form an interlocking system. Numerous corner blocks are L-shaped and appear as if they were bent by the builders with more cutting surfaces. Here is a diagram of the 16-sided granite monolith in the Valley Temple. It's hard enough to create two adjacent blocks with one conjoining surface to fit that perfect. Why would the ancient stoneworkers make their jobs significantly more difficult and chose to produce so many irregular-shaped blocks? Did they have better and easier ways, other than carving, to create these precisely fitted polygonal blocks? Was there a method of masonry used that we have not yet identified? The ultra-fine seams and sharp right-angle edges have convinced many modern masons that such stonework is way beyond the ability of the Bronze Age Egyptians, as even with today's technology, it's still extremely strenuous to duplicate the work with that skill and level of precision. Granite is very hard to cut and has a high compressive strength, but its tensile strength is much lower, could be as low as 4% of the compressive strength. This low tensile strength makes granite brittle and prone to fracture. If the granite pieces were not handled with great care, they can readily break during transportation and maneuvering. I read some masons' comments and learned the following. The right-angled corners and square sharp edges of granite blocks are the most fragile parts, since they chip easily. A slight bump during positioning of the block can result in broken corners and edges. Modern stone slabs and blocks usually have bevel or slightly rounded edges. For all these square-cornered blocks in the Valley Temple to be perfectly aligned and positioned while staying intact is unthinkable, even using current machinery and tools. But whoever built the Valley Temple seemed to be able to do it with ease. Since the square corners and precise joints between massive granite stones, L-shaped and polygonal blocks are abundant inside the temple, how did they possibly do that? How did the ancient masons generate these laser-accurate conjoining blocks with the right corners? The bent cornerstones of the Valley Temple can also be found inside the Sphinx Temple. This temple is right in front of the Sphinx, next to the Valley Temple. Its granite sheathing stones were taken by stone robbers, which left loose granite blocks and bare limestone cores. In front of the Sphinx Temple, there are a few large granite blocks that feature curved profiles. Even after being broken, battered, and weathered, the remaining granite curvature still looks elegant, flawless, and smooth. Engineer Christopher Dunn examined one of the curvy blocks and found remarkable consistency along the radius. Not far from Carve Pyramid, there is another mysterious big granite block. Originally, it might have been portion of a corner column. The rounded column part is smooth with consistent curvatures. What advanced stone masonry techniques were used to make these stunning stone pieces? At the Carve Pyramid, there are granite casings at the bottom. Ancient Egyptian stone robbers tried to use the feather and wedge method to cut away the granite, which left these wedge marks. I noticed something interesting here. The granite casings were made to fit and fill in the uneven core stones in the back, because the conjoining lines between the limestone and the granite are not straight but zigzag. This means many granite casing stones will need to be custom-made, as their shapes will depend on the backing core stones, which would be much more time-consuming and laborious to do. This practice is similar to the sheath granite blocks covering the eroded limestone in the Valley Temple and the Sphinx Temple. By the way, the same custom-made granite casings are used at the Menkaure Pyramid as well, with the visible zigzag separations between the core stones and the granite. In this clip, we can see an exposed granite casing stone fit right into the irregular limestone in the back, which resulted in the ragged and uneven conjoining lines between the two types of stones. How much effort was needed to create these carved-to-fit granite casings? Speaking of Menkaure Pyramid, I think it contains the most illuminating granite work on the Giza plateau. Menkaure is the smallest great pyramid along with the pyramids of Khufu and Khafre. Here we can see the rose granite casing stones covering the bottom portion of the pyramid. They have no chisel marks and are in different sizes. Most have a clay-like bulging look. Some have uneven surfaces, as if the blocks have been scraped. Some have various shaped knobs that are quite strange, which I discussed in a previous video focused on different knob types of megalithic sites. The link is at the upper right corner if you want to watch that video. About the granite work at the Menkaure Pyramid, there are rows of flat-planed stone blocks next to puffy-looking blocks. The areas of the finished, flattened stone blocks with tight, adjoining seams resemble that of the Valley Temple. The truly interesting thing is that some bulging blocks appear to be partially flattened while the work stopped, and left some blocks flat on one side and bulging on the other. This could be the best evidence showcasing how these granite blocks are formed to be flat, smooth, with tight joints. It appears that the stone blocks were soft and malleable at the time of construction, which was then flattened and smoothed out to achieve the desired finishing look. This reminded me of a procedure used in modern concrete projects called screeding. Screeding redistributes, compresses, and removes any excess pliable material like concrete and makes the surface flat, smooth, and leveled. The blocks at the Menkaure pyramid seems to be frozen in the mid-process of screeding. Some got flattened, and some remained in their original cast forms. These screeding marks point to the possibility that the granite casing stones of Menkaure pyramid were created with concrete-like materials, not natural stone. Casting could also be a much more efficient and effective method to generate casing stones to fill and fit the uneven core blocks. Some may argue that granite cannot be cast like limestone since it's an igneous rock. However, that's not true. Cast stone or reconstructed stone that looks and performs like natural granite, sandstone, and other stone types have been around for a long while. The use of cast stone as a building material dates back thousands of years to ancient Rome, where pozzolanic cement was used along with other natural aggregates. If we count terrazzo as a kind of cast stone, then cast stone history can be traced back over 10,000 years. Cast stone is a cost-effective alternative to natural stone, often preferred in construction due to its durability, versatility, strength, and appearance. Here are some projects made with cast granite. It looks and performs similarly to natural stone, with additional bonuses. As cast stone is free from the naturally occurring imperfections and stratification found in natural quartz stone, it has neither variations nor defects. Other benefits are, cast stone can be produced in molds or sculpted, thereby having a vast range of shapes and sizes. Choices of color and material matching has improved thaw-freeze resistance, easy to manufacture and install, etc. By the way, the UKCSA, United Kingdom Cast Stone Association, and the ASTM, American Society for Testing and Materials, both have established technical standards for cast stone. So, cast granite is possible and has been in use. Then could the unusual granite casing stones of the Menkaure pyramid be cast? Even though there is no material study on the Giza granite yet, casting would explain the screeding and flattening marks, the scraping imprints and indents observed here. The puffy bulging blocks could be the result of demolded cast stones. This shouldn't come as a shocker, since we know that the large Egyptian pyramids used cast materials. As I presented in prior videos, multiple scientific studies discovered that the core stones and casings of several pyramids are artificial, reconstituted limestone. If we look at the surviving casing stones of the Great Pyramid, we can see that the crisp and tight conjoining lines between blocks are on par with the precision level of the Valley Temple stones. It would be more conducive to obtain the laser-accurate square corners and barely noticeable seams if these big blocks were cast instead of carved, especially if the blocks were cast in situ. That way, the masons don't need to deal with maneuvering heavy precast stones, and any problems could be fixed right away. For example, chipped corners or other blemishes. Let me show you some clips of workers creating or say sculpting columns with sand and cement. Cast stone are made of natural aggregates, cementitious binder, water, pigments, and a waterproofer. Its consistency and texture can be adjusted and may not be that different from the sand and cement we see in this clip. Therefore, the method used by the cement worker here could very well be applicable to cast granite projects. Remember those big granite blocks with consistent curvatures? If they were cast, then their production would be pretty easy. A curved stencil will suffice to do the job. The malleable cast material can be scraped off, similar to how the worker created cement windowsill molding. Furthermore, this cast and sculpt in situ technique can limit the need for different shaped molds. as the mason can create complex shapes using simple tools like a trowel and a long square stick. Inside the Great Pyramid of Khufu, there are 5 relieving chambers directly above the king's chamber, containing the heaviest granite blocks of the pyramids. Each relieving chamber has 8 to 9 granite beams laid tight to each other across the whole span. These enigmatic granite beams each weigh about 50 to 80 tons. To give you an idea on how heavy they are, a loaded 18-wheeler truck cannot exceed 80,000 pounds, which is 40 tons. So each granite beam would weigh as much as 1 to 2 loaded 18-wheeler trucks, and there are 43 such heavy beams. Egyptologists state that these granite blocks were quarried, transported from Aswan, and then dragged to the top of the plateau 4,500 years ago. This sounds questionable. The bottoms of these beams are flat and tightly placed together. The cracks between blocks are probably resulted from the 2 major earthquakes, which occurred in 908 and 1301 AD. Originally, these stones likely fit as precise as the ones in the Valley Temple. People have been wondering how these substantially heavy stones were put up there. Inside the Lady Arbuthnot's chamber, multiple linear grooves in granite can be seen. Similar cross grooves are present on several granite beams of the Campbell's chamber too. Some bold-looking indents in the granite beams are also observed in the Campbell's chamber. From the limited photos I found online, the grooves lack chisel marks and seem smooth. They look like that someone scraped parallel imprints when the stone was malleable and somewhat resemble the scoop marks at the Aswan quarry where the unfinished obelisk locates. Do you agree? Besides, the bowl-shaped indentations with curvy edges look as if some material had been scooped out with a shovel. Could these curious marks be signs or clues of cast granite work? But if these hefty granite blocks were cast, why are they in different sizes? Did masons create multiple molds to cast these beams? Why not use unisized molds? No matter what, casting these blocks in different molds in situ will still be infinitely easier than cutting, lifting, and positioning natural granite blocks to fit. Another factor which might add to the cast granite hypothesis is that Giza granite seems to have no veins at all. Natural granite has unique color, texture, and veins. If none of the Giza granite have veins, it raises the important question whether they are reconstituted granite, especially when the pyramid builders had already created sophisticated artificial limestone for the core and the majority of the casings. Cast granite could explain why these Valley Temple stones fit so impeccably together with the minimal seams, how the granite casings were made to fit the eroded core stones, and how these curved granite blocks have such consistent curvatures. On top of that, casting can answer the mystery of the partially flattened and partially bulging granite blocks of the Menkaure pyramid. Therefore, I think it's conceivable that the extraordinary granite work of the Giza pyramids and the Valley Temple are cast. What do you think? If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.